Hi, welcome to the video. This is the sixth video in your Mastering CISSP series, okay, and sixth video towards your cryptography. Now, there are two different types of cryptography. Before we start getting on to the stream cipher and block cipher, I would like to touch upon this basics of different types of cryptography. One type is called symmetric encryption. The other one is actually called as asymmetric encryption. Now, what is a symmetric encryption? Symmetric key encryption or cryptography. Cryptography. Okay, so for the sake of discussion, we'll take it as a cryptography. Then it then mean, is it only symmetric key encryption and not decryption? So be careful. So symmetric key cryptography, otherwise known as, or also known as, okay, shared, okay, secret, and private key cryptography. Okay. Now, in symmetric cryptography, the same key is used for encryption and decryption. So, for example, if Ram is actually sending a message to Ahmed, okay, so Ram and Ahmed should have the same key. So, if they both have to have the same key, they cannot obviously generate the same key. So, somebody has to generate the key. Any one other person has to generate the key and share it with the other. Because the same key is used for encryption and decryption, it's actually called as symmetric key cryptography. And because the key has to be created by one person and shared with the other. See, the sender has to create the key and share with the recipient. Okay. Or recipient can also create a key and share it with the sender, but it depends upon who's sending them. So sender and receiver does not mean the key originator or key creator, basically. Okay, so it's called shared key cryptography because one of them should create the key and share it with the other. It's also called as a secret key cryptography because the sender and the receiver should maintain this key as a secret with them. And it's called the private key cryptography for the same reason. They have to keep it private. This part will be a little bit confusing because the public key cryptography, okay, so it's otherwise will lead to what is called as an asymmetric encryption. So private key cryptography means symmetric key cryptography. Okay, so I missed the word key here. Okay, so private key cryptography is symmetric key cryptography. Okay, in the examination, I'm going to give you a question just to confuse you around that word private and public part of it, and we should be careful. Okay, now I said A. Okay, let's say Ram. Okay, will generate the key and share it with Ahmed. Okay, so Ram is going to have the key. Ram is the sender here, and Ahmed is the originator. If Ram is going to speak to Ahmed, they both have to have only one key. So one key is enough. Okay. For example, if there's a James who actually comes in between, so Ram has to generate the key and share it with the James. So that becomes one key, and Ram has to generate a key and share it with Ahmed. That becomes two keys. And if Ahmed has to communicate with James, then it becomes one more key. So it requires three keys. So ideally, there's a formula for arriving at number of keys required for a group. As far as symmetric key cryptography is concerned, it's n into n minus 1 divided by 2. Okay, so for a two-member communication, so 2 multiplied by 1 divided by 2 becomes one key. So Ram and Ahmed is only one key. For 3 multiplied by 2 divided by 2 for a 3-key environment. Okay, so that actually becomes 3 keys. So Ram to Ahmed, Ahmed to James, and James to Ram. Okay, and similarly for 4-member team. Okay, so it becomes 4 into 3 divided by 2. That becomes 6 keys. Okay, so ideally, the key for arriving at number of keys that are actually required for a symmetric key cryptography, okay, is n into n minus 1 divided by 2. Assume there are 100-member environment, so 99 multiplied by 50, okay, will be the number of keys that are actually required. That comes to 4,950 keys. So in symmetric key cryptography, the biggest disadvantage is if number of users, number of participants are more. Okay, the key management becomes a bit of an hectic one. Okay, it's a very cumbersome one. Okay, somebody has to maintain the key as secret. Okay, so anyway, we are maintaining the key as secret even in asymmetric encryption. The symmetric encryption, as I told you, the disadvantage is the key management, but the advantages are it's really faster. Okay, symmetric key cryptography is faster. Okay, so you can implement that on the software. When I say software, asymmetric encryption can also be implemented software-wise, but on a bigger environment where the intensity is more. Okay, number of transactions are more, number of encryptions that needs to be done is more. It is implemented on the hardware security module. So asymmetric encryption is implemented the hardware security module just to have an advantage of the superior processing power of the hardware. In fact, the crypto core process, which I had been involved with since my AS400 days, mid 90s. Okay, crypto core process are there as a part of the system, but now we have the TPM chip as a part of the hardware. So it is now very prevalent to implement things on the hardware level, cryptography at least the hardware level. But symmetric cryptography, okay, it's very faster, so it can be implemented on the software level. So it is not mathematically intensive. That is also one of the reasons why it can be implemented on the software level. And what else? Okay, so you have to maintain this as a secret. Okay, but the only thing is you have to securely pass this information, that the securely pass the key that the originator or the creator of the key has generated with the recipient. Okay, that's where the actual challenge is. Okay, but now ideally we use the combination of symmetric cryptography and asymmetric cryptography in the real world. Okay, so slowly and slowly in every video we'll start watching about the asymmetric crypto system and how we're going to use it together. Okay, it's a beautiful platform. So no cryptography, no confidentiality, no integrity, no source origin authentication, no accountability, and no non-repudiation. But in symmetric cryptography, it maintains or establishes only the confidentiality and nothing else, because we don't speak about the integrity of the data here. It also does not establish a source origin authentication because the sender and the receiver use the same key. So there's no accountability, and for the same reason, non-repudiation is also not there. So symmetric cryptography establishes only the confidentiality part of the complete cryptography. Okay, so confidentiality part of the information security rather. Okay, not the integrity, non-repudiation, accountability, and then source origin authentication, which is otherwise established in asymmetric encryption, but the hashing is not. I mean, the integrity is not. That's with the hashing. So when we come to the stage of a digital signature, okay, so we can understand the complete picture of the symmetric cryptography, asymmetric cryptography, and hashing together. How do you achieve all the 5 principles of information security? Okay. So thank you and cheers for your day, and thanks for watching this video, and stay connected for the further videos and for your CISSP training. Thank you very much. Cheers. Bye-bye.